session of this very interesting conference on the internet from the International Energy Association. I'm very happy. My name is Herman Volleberg. I'm professor of economics in environmental economics in Tilburg and also associated with the Netherlands Environmental Assessment Agency. It's a well-known institute for climate change analysis, by the way. So one of the most important models which are used for all these planning things, the image model is in our institute. So I'm quite related in my work to what they are doing, and as an economist that's a bit different than integrated assessment. But anyway, it's very interesting stuff to think about climate policy, and that's exactly the title of this plenary session. And I want to thank everybody to stay here for so long, because we have already 3 full days of papers and listened to many interesting contributions. But I can promise you there will be 3 more at least. I will start with a very short introduction, so I don't count that one, but after my own simple presentation, there's a lot more to inform you about what would be a good strategy. We're talking a lot about climate change. Some people have the idea that it may be fake news, or that we are a sort of rocket man leaving the planet, the heating planet or something like that. But if you look at the facts, it's a bit difficult to deny that something is going on. We are not scientists, and we are also not going to discuss the scientific part. I would love to. I know a little bit about it. But at least from these kind of figures, that is, we see some kind of temperature change over time in the last 100 years. I think that everybody these days can notice the difference. At least at my age, I already see a big difference than relative to when I was young here. In the Netherlands, the temperature on average is already 1.5 degrees above 50 years ago. So there is really some kind of change, and we see it in the sea level. We see it in the upper ocean heat content. We see it at many points in the global atmosphere and the ecological system, which are warnings, and we also planned to do something to it. And my own point is also that we have a huge challenge. We have seen in the first plenary session already some discussion of this. I think these 2 slides summarize exactly where what this challenge is. On the left-hand side, you see the best projections we have so far on the growth of the world population. And if you look at that graph, it means 11 billion people in 2100, where we are now at something like 7 billion, so that's 4 more billions. And on the right-hand side, you see the projections of the different integrated assessment models we have on what they think will be the emissions of CO2 over time in this area. And the message model is usually seen as an outlier. But according to my own estimations and forecasts we have been making in Tilburg, they may not be so far out of our predictions. And that is what you see in the bandwidth on the right-hand side. Of course, all conditional on whether Paris may be a success. And this is where we are going to talk about today. Some questions. We see the temperature goal of 2 degrees seems great. I think that is great if you look at these projections of the integrated assessment models. They very easily show temperature changes up to 10 degrees in 2150. 10 degrees, that's 5 times 2 degrees. And the question is how to make Paris a success. In Paris is basically a procedural agreement, and it's not explicitly agreed upon the instruments that you could apply to reach the target. And as economists, we usually, we call it in Dutch, boter bij de vis. That means that you really want to see something concrete, some specific instruments like a carbon tax or something like that. And it was not really on the table. Instead, we have these nationally determined contributions, and they are regularly evaluated. But on the other side, if you look, for instance, to the Netherlands, my own country, there is a lot of discussion even on specific instruments like a minimum carbon price and ETS even for the Netherlands alone. So there is something going on, but it's not very clear what will be the outcome of this. And the challenge of incentives is, of course, very, very large, and we will see more of it. Here is the carbon price picture. Carbon pricing is basically the polluter pays principle applied across the world. That is, as an economist, the first best instrument, you would say. If there's pollution, okay, don't wait until the victims are there. That will be the next generation. So usually the policy advice is to tax carbon in a way, and that is taxing pollution. And here you have an overview of the development. And there is indeed some hope if you look at it. And the next slide shows you the most well-known system in the world, I think the European emission trading system, which has been implemented already in 2003. And since it's established and changed over time. And there's a lot about this discussion on the price. And we will see, obviously, today another discussion whether this price is indeed what we like. On the right-hand side, you see some interesting change. This is really the newest slide, I would say. Usually I had this slide and it ended, let's say, in the end of 2017 at around €6 per ton. But nowadays it's almost 15, 16. So there's a big change. And we will discuss also today what is the reason behind this change and whether indeed minimum prices are still appropriate. Now let's see what we can do today. We have three presentations. First we have Ian Perry from the IMF. And I'm very happy that he will be here. He is well dedicated to the climate policy taxation issue in the world. And he will tell us, first of all, what is going on in this area at a global level. So Ian, if you can take over from me, that would be great.
So, how do I?
Somebody upstairs is there? Just. Yeah, exactly. So we have to go here. No, don't come there.
Good.
Yeah, if you start talking, then it will be okay.
Okay, right.
You will put it on the internet.
Yeah, so I'll talk about policies for implementing the Paris mitigation pledges.
Yeah, I put it. So,
Yeah.
there you are.
Very good, thanks.
Yeah. Okay.
So 190 countries submitted emissions mitigation pledges for the Paris Agreement, and amongst G20 countries that account for about 80% of global emissions, a typical pledge is to cut emissions by something in the order of about 30% by 2030 relative to emissions in some baseline year. And these pledges, they are voluntary, but countries are required to report their progress on implementing these pledges every 2 years, starting this year in Poland, and to submit revised pledges every 5 years, which are expected to be progressively more stringent. Now, I think that the fiscal and environmental rationale for implementing carbon pricing as the centerpiece of mitigation efforts is really becoming increasingly accepted across the world. We now have over 50 carbon pricing schemes either implemented or slated for implementation shortly. And typically prices in these schemes, in carbon tax schemes and trading schemes, are typically in the order of about $5 to $30 per ton of CO2 at present, substantially more than that in Scandinavian countries and Switzerland. But these, I'm talking about pricing schemes at the national and subnational level, but these pricing schemes cover only about 15% of global emissions at present, and the global average emissions price is only $1 per tonne. So we really need to transition to a much greater coverage of emissions pricing and much higher emissions prices. And in our view, to help move this process forward, we think that it's especially useful for policymakers in different countries to have quantitative information analysis of the emissions, fiscal and economic impacts of carbon pricing policies, and quantitative information on the trade-offs between carbon pricing and other commonly used mitigation instruments, such as taxes on electricity, taxes on individual fuels, incentives for energy efficiency, and so on. Because this information is really critical for governments to help design the specifics of carbon pricing, to decide what carbon price trajectory they need, to assess what sorts of revenues will be raised from carbon pricing for accompanying measures like reductions in other taxes or increased public expenditure. And it helps them to communicate the case for pricing versus other emissions mitigation instruments to the general public. In addition, this sort of quantitative analysis of the emissions prices that are implicit in countries' Paris mitigation pledges is helpful at the international level to inform dialogue on future revisions to the emissions pledges. And there has been a lot of modelling of carbon prices at the global level and the regional level and the large country level, and this is all very useful, but not all of these models are particularly transparent. Often it's difficult to replicate these models across a large range of countries to provide consistent estimates of the impacts of carbon pricing across different countries. And typically these studies don't look at a wide range of alternative mitigation instruments, and they don't always look at the three metrics I've mentioned. They look at emissions, but they may not quantify impacts on revenue or economic impacts. So at the IMF, we've developed this spreadsheet, this very streamlined spreadsheet model to try and provide some sense of this information at the individual country level. So this spreadsheet model, it's very simple. It starts out with fossil fuel consumption in the power generation sector, in the road transport sector, in the household sector, and the industrial sector, and that's available for over 150 countries from the IEA website. And then we just project fuel use by sector forward using projections of GDP growth at the country level, assumptions about the income elasticity of demand for electricity and fossil fuel products, assumptions about the autonomous rates of technological change that, for example, improve energy efficiency across different sectors, and assumptions about future international energy prices. And then in this model, the impacts of policies, carbon pricing and other mitigation instruments will hinge crucially on our assumptions about the elasticities of demand for electricity and fossil fuel products. And we just choose these to try and roughly mimic the sorts of behavioral responses that emerge from much more sophisticated economic models and also econometric evidence on these elasticities. So typically, we're assuming elasticities in the region of about -0.5 to -0.7. I think a key attraction of this approach is that it's very transparent. We can explain the impacts of carbon pricing in terms of concepts that are readily understandable by policymakers, such as fuel price elasticities. We can easily explain why carbon pricing has different impacts from other mitigation policies and why countries need different emissions prices for their mitigation pledges. And in addition, this simple spreadsheet model can incorporate very readily a wide range of different countries just by pulling off fuel use data from the IEA website, a wide range of mitigation policy instruments, a wide range of alternative parameter values, and also we can look at the three metrics that I mentioned: impacts on emissions, revenue, and economic welfare. Obviously, there's some caveats. The model is highly simplified. We're not, for example, looking at the gradual adjustment of capital stocks over time. Effectively, we're assuming that fuel use adjusts instantly to changes in fuel prices, but I think that's reasonable given our long-term horizon, looking at policies that are phased in gradually out to 2030. And we're not looking at international trade either. And of course, there's the inevitable inherent uncertainty over key parameter values. So this figure is showing our projections of the change in fossil fuel CO2 emissions in our business as usual case, indicated by the black squares. So this is with no new mitigation policies introduced in the future, beyond those that are already implicit in our current fuel use data. And averaged across the G20 countries, emissions expand by about 35% between 2015 and 2030. That's substantially less than the expansion in GDP, indicated by the blue bars, because the ratio of primary energy use to GDP is declining considerably across this period, across all countries. That's indicated by the red bars, and that's reflecting our assumption of below unitary income elasticities for our energy products, our assumption that there's gradually improving energy efficiency across different sectors, and in addition, our assumption that international energy prices are rising slowly over this period, dampening the demand for fossil fuels. When we look at the economic impacts of our carbon pricing and other mitigation instruments, in our view, it's very important to take into account the domestic environmental benefits of those policies, most significantly the reduction in air pollution mortality. To us, that's part of the change in economic welfare from these policies. So this is just our estimates of the air pollution mortality rates in different G20 countries in the business as usual case in 2030. So most significantly, we're estimating that in the case of China, there would be about 1.3 million deaths caused by fossil fuel air pollution in 2030 in the business as usual case, mostly from burning coal. But even in an advanced country like the United States with quite well-developed emissions control regulations, we're still estimating that there would be about 25,000 premature deaths from fossil fuel air pollution in 2030. This figure here, I guess this is, I think, probably the most important figure that I'll show. This is, the black squares in this figure indicate the percentage reduction in emissions, fossil fuel emissions, below business as usual levels in 2030 that would be implied by G20 countries' Paris mitigation pledges. And the blue bars indicate the percentage reduction in emissions that would be induced by a $35 per ton carbon price in 2030. And the red bars indicate the additional emissions reductions that would be induced by a $70 per ton carbon price in 2030. So you can see that in a number of cases, $70 per ton carbon price would be more than sufficient to meet the mitigation pledge. For example, in China, India, Indonesia, South Africa. In some other cases, $70 per ton is just about sufficient or almost sufficient to meet the Paris pledge, for example, in Turkey and the United States. But in other countries, $70 per ton falls well short of what would be needed, for example, in Australia, Canada, and European countries. And these differences in the implicit carbon prices that are consistent with countries' Paris mitigation pledges reflect not only differences in the stringency of emissions commitments indicated by differences in the black squares across countries, but also differences in the price responsiveness of emissions across countries indicated by differences in the blue and red bars. In particular, countries that use a lot of coal, like China and India and South Africa, in those countries, emissions are a lot more responsive to pricing, and that's because carbon pricing has a dramatically larger proportionate impact on the price of coal than it does on the price of other fossil fuels. And finally, at the bottom there, we see that averaged across the G20 countries, a $35 per ton carbon price would be just about sufficient to meet the Paris mitigation pledges. But this is reflecting the disproportionate influence of China and India, given their large share in emissions, who have relatively less stringent commitments than advanced countries. Now, if G20 countries were to phase in, for example, a $70 per ton carbon price by 2030, this would have a huge fiscal benefit. It would be raising revenues of approximately 1 to 2.5% of GDP in 2030. In most cases, substantially more than that in a few other cases like India and South Africa. So that's a very attractive new revenue source which might be used, for example, to significantly cut the burden on the economy from broader taxes on labour and capital, fund growth-enhancing investment, or reduce fiscal deficits. So we think that's an important attraction of carbon pricing. This figure indicates the domestic economic welfare impacts of carbon pricing, taking a snapshot of 2030, where welfare effects are expressed as a percent of countries' GDP. So the red bars here are just the pure economic costs, reflecting losses in producer and consumer surplus in fuel markets. And even for the $70 per ton carbon price, these losses aren't that big in most cases, typically below about 0.5% of GDP, although there are more significant losses in 3 cases, about 1% of GDP or more. That's the coal-intensive countries, China, India, and South Africa. But in my view, it's very important to take into account the domestic environmental benefits of carbon pricing. It's a bit of a controversial viewpoint to take, because other people say, well, for domestic air pollution, we should be using other instruments to internalize the externality rather than carbon pricing. And obviously that's correct, but it's clearly not the case that countries are going to perfectly internalize air pollution and traffic congestion externalities, other externalities, through Pigouvian pricing anytime soon. The only country that comes anywhere near close that I'm aware of is Chile, which has a system of air pollution fees scaled to estimates of air pollution damages. But apart from Chile, I don't know any other country that comes anywhere near close to fully internalizing air pollution externalities, traffic congestion externalities, traffic accident externalities through Pigouvian pricing. And I don't think anytime soon that countries are going to implement perfect Pigouvian pricing. So my view is that it's entirely appropriate to take into account the non-internalized domestic externality benefits when we're phasing in carbon mitigation instruments. And when we do this, it offsets the pure economic mitigation costs of carbon pricing in most cases. In all but 3 cases, even under the $70 per ton carbon tax, we have domestic environmental benefits either roughly offsetting mitigation costs or substantially exceeding them in cases like China, India, and South and Russia. That's indicated by the blue bars here are the net impacts, the domestic environmental benefits, lesser mitigation costs. Those are some very substantial net benefits in countries that have very substantial air pollution problems. This table here is comparing the effectiveness of a range of other mitigation instruments with the effectiveness of a $70 per ton carbon tax at reducing fossil fuel CO2 emissions. And here, for transparency, we've scaled the other instruments such that they impose the same implicit or explicit price on the CO2 emissions that they cover as the $70 per ton carbon tax. So you can see that, for example, in the case of a pure tax on coal, in most cases, that's substantially less effective than a more comprehensive carbon tax, but there are some exceptions where a simple tax on coal use would achieve 75 to 95% of the emissions reductions under a carbon tax, for example, in Australia, China, Germany, India, Korea, and South Africa. In fact, for example, in China, they already have a tax on coal at the mine mouth and on imports, so it'd be straightforward for them to build a carbon charge into the coal tax, and that would, in China's case, have 95% of the effectiveness of a more comprehensive carbon tax. The second column there is the effectiveness of an emissions trading system, where I'm assuming here that the trading system covers just emissions from the power sector and large industry. It doesn't cover small industry, households, or the road transport sector, because that's the way trading systems in most cases have been implemented to date. And that policy has effectiveness of about 50 to 70% of the effectiveness of a more comprehensive carbon pricing policy. A simple tax on electricity output, and many countries have excises on electricity output, often warranted on environmental grounds. Well, that policy has effectiveness of something like about 20 to 35% of that of a broad-based carbon pricing policy. Much more effective is to tax CO2 emissions from the electricity sector. That policy has effectiveness that's almost as large as that of trading systems. Road fuel taxes are relatively ineffective. Their effectiveness is typically less than 10% of that of a broad-based carbon tax. That's partly because they're only covering on average about 30% of emissions, and in addition, they have only a moderate impact on driving up the prices of road fuels. Carbon pricing has a relatively modest impact on driving up road fuel prices in percentage terms. And finally, an energy efficiency policy comprehensively applied across all sectors has effectiveness of about 20 to 40% of that of a broad-based carbon tax. This table's comparing the revenue impacts of other mitigation instruments to the $70 per tonne carbon tax. And basically, there's no other instrument in any other country that comes close to raising the same amount of revenue as a comprehensive carbon tax. Even in coal-intensive countries like China, South Africa, and India, just taxing coal alone raises about 65 to 75% of the revenues that would be raised under a comprehensive carbon tax. In emissions trading systems, even if the allowances were fully auctioned, these policies are raising revenues of about 40 to 60% of the revenues under a comprehensive carbon tax. And an energy efficiency combination, for example, doesn't raise any revenues. So just to sum up, we all knew this in a qualitative sense beforehand, but I think it's useful to have it spelled out in a quantitative sense on a country-by-country basis. But we've seen that there's a very strong environmental, fiscal, and economic welfare advantage of carbon taxes or comprehensive trading systems that cover all emissions over other instruments. So we feel strongly that for any country, not just advanced countries, but pretty much any country of these 190 countries that have mitigation pledges, that the centerpiece of their efforts should be a broad-based carbon pricing policy. And we've seen that for a large number of countries, carbon pricing may well be in their own interests up to a point when we take into account the domestic environmental benefits that can offset or more than offset the mitigation costs. In addition, we've seen that in a number of countries, very high prices will be required to meet their mitigation pledges, at least based on what we think are reasonable assumptions about the price elasticity of fossil fuels. So I think this underscores the need for complementary policies to help increase the effectiveness of carbon pricing, or put another way, reduce the prices that are consistent with countries' mitigation pledges. So I have in mind here aggressive R&D programs to develop low-emission technologies, expansion of infrastructure to help promotion of renewables and electric vehicles, and so on. And then the third final conclusion is that we've also seen that there's very wide dispersion in the implicit carbon prices implied by countries' mitigation pledges. So in my view, that really underscores the case for supplementing the Paris process with a carbon price floor arrangement at the international level amongst the major emitting countries. Carbon price floor arrangements provide some degree of reassurance against losses in competitiveness, while also allowing individual countries the flexibility to set prices higher than the floor price, which they may need to do to meet their Paris mitigation pledge, or they may want to do for domestic environmental reasons or fiscal reasons. And given provisions within the Paris Agreement that allow countries to trade excess mitigation credits, called ITMOs, a carbon price floor may well encourage participation amongst developing countries for whom the price they need for their mitigation pledge is well below the price floor, because by participating in the price floor, they can make big profits by selling their excess mitigation credits to countries for whom the price floor is well below what they'll need for their mitigation pledge. Okay, thank you.
So thank you, Ian, for this wonderful overview, global overview of what is needed. So if you keep in mind that something like $36 per ton would already be enough, you would think, okay, let's start today. That is on the carbon pricing side of the story. But you also mentioned that the R&D side also requires some investments in a sense. And fortunately, we have Caroline Fischer telling us something about that side of the story. So, Caroline, can you come here? Let's see. I can find it here. Oh. Do we get it? Control.
Where's the sent of PowerPoint?
No, he doesn't.
Okay.
No. What is control? It's a PDF. This is a PDF?
Yeah, Control L.
Oh, Control L. That is. Yeah. Okay.
Okay.
Yeah. Okay. Floor is yours.
Okay, thanks. Thank you all for being here, sticking around. I'm going to talk a little bit about strategic clean technology policies. I think I may be contradicting Ian a little bit on something, so there should be a good discussion afterwards. But, you know, as a card-carrying environmental economist, we tend to go around and really emphasize wanting to get the prices right. So just as Ian was telling us. But when we look around and see the interventions that are taking place, yes, we have made headway, and we see a lot more carbon pricing. So this is a version of that map that Herman had a better one up of. But you see that carbon pricing is spreading globally, but the average prices are still pretty darn low. They're not up at what we might think of as being the social cost of carbon, or at prices that even would get us on the path. And currently, only about 12% of global emissions are covered. So that means a lot of emissions are unpriced. What we do see, policies that are very popular around the world, are actually support for renewable energy. And we see that almost all countries have jurisdictions that are providing subsidies or mandates for renewable energy. Now, some prominent economists are not so enthusiastic about this. This was a blog by Rob Stavins basically arguing that the EU should scrap the renewable energy targets and energy efficiency targets and just let the ETS do its work. So part of this is that you notice that all the jurisdictions that have emissions pricing also have support for renewable energy. And part of his argument behind that is that, you know, these especially if you're using an emissions trading system, these policies interact. So when you're requiring a lot more renewable energy in your power sector, That's basically, you're telling the electric sector to use more renewables than it would otherwise with the ETS. That means it has fewer reductions to do, and that tends to drive down the price of allowances, and then you're not using the emissions trading system to its full extent to get emissions reductions. On the other hand, though, there are some economic rationales for subsidizing renewable energy or green goods in general. And so this is where we get into very much a second best world where the emissions externality is not our only market failure. There may be other market failures that we may legitimately want to address with overlapping policies like subsidies. And so I like to divide these rationales into sort of upstream and downstream, and you'll see why in a minute. But this is building on some work that I've done with some folks in the audience, Knut Deiner, Rosendahl, and Mats Greaker. We have a couple of papers, and I've been extending that work. And so it's useful to think about upstream market failures. These are issues, say, with the technology suppliers. So these are new technologies. They're still being innovated. There may be spillovers to R&D from these technologies. There's empirical evidence, probably by folks out here too, that there may be greater spillovers from clean R&D than conventional technologies. There may be scale economies, learning by doing spillovers. There may be network externalities as we roll out these technologies. And also, since these are new industries and typically under patent protection, their technologies, there may be some imperfect competition. So maybe market concentration is not a perfectly competitive market. So these are all reasons why the upstream market providing these technologies may have an incentive to kind of underprovide quantity. And so we can distinguish this from downstream market failures, which are a lot of the ones that Ian was talking about. So we have underpriced emissions, both for CO2 and other maybe conventional air pollutants. Even worse than underpricing CO2, we are also still subsidizing a lot of fossil fuels. So these renewable clean energies and dirty energies aren't necessarily on a playing field to start out with, an even playing field. And then there's also on the demand side, there's a lot of research into behavioral gaps. So is there do we have enough demand for investment in energy efficiency, or are there some market failures there to address? So on top of these additional market failures, we may also have, policymakers may have some other goals, including jobs and exports. And so I think this is in part why we see such a big focus on, let's call it green industrial policy, rather than taxing brown industry. Another interesting factor, though, is, so if we look upstream and downstream, we can also think about policies where they intervene, upstream in terms of the technology providers, or downstream in terms of the technology adopters. And if we look around, and the EU is a great example of this, what we see is that really the vast majority of public interventions and spending has been on the downstream side, on the deployment side, and not on the upstream side in terms of the technology providers and R&D. So you see, this was data compiled from a little while ago, but this is basically the EU policy mix for renewable energy. And, just like orders of magnitude, larger amounts are being spent on deployment than on R&D. So part of the question is this the right mix? So what we see is that, so a lot of boosters of really focusing on the downstream market and deploying renewable energy is that, okay, we are getting to scale in these technologies. We are lowering the costs. We're learning about them. And, you know, you do see these relationships between an expansion of capacity in renewable energy, cumulative capacity, and then you see the costs also declining on the right-hand side. On the other hand, these studies tend to ignore what's going on the upstream side. So we see experience curves, and there are very few studies sort of really do a careful job of distinguishing about whether it's push or pull and where the incentives are coming from. So here you have another story that a big reason why solar costs have declined, it's not necessarily that Germany is subsidizing PV installation on rooftops, it's that China is subsidizing its industry upstream, and to quite a large extent. In fact, to such a large extent that it's causing trade disputes. So there was a sort of heated dispute between China and the EU. Also, the US chimed in on this, accusing China of giving illegal aid to the solar industry. And they were going to take this to the WTO. They ended up kind of settling and deciding to carve up the global market. But this is one of the issues with the upstream interventions, that trade law sort of frowns on industrial policy in general. And we see sort of this conflict between, liking green industrial policy for its greenness, and many people like it also for the industrial policy side. But in the trade side, trade lawyers and trade economists are very hesitant to sanction industrial policy. And so we actually see a number of disputes now in the WTO related to renewable energy. Okay. So here now I'm going to turn to a modeling exercise to think about, how should we feel about these upstream versus downstream interventions? So upstream interventions, again, are things that tend to drive down the cost of the technology directly for upstream. So this could be production incentives for the wind turbine manufacturers. It could be below cost inputs, preferential finance. It could be R&D support. And this is distinct from downstream incentives, which are incentives to adopt the technology. So this would be feed-in tariffs, renewable portfolio standards, production tax credits, other investment incentives, et cetera. And the distinction is that when you subsidize upstream, you're bringing down the cost of the technology. So you're shifting out the supply curve, running down the demand curve. This tends to drive down technology prices. When you subsidize downstream, on the other hand, you're bidding up demand for the technology. This tends to pull up technology prices. So if everybody's doing this, and you just have one world or one jurisdiction, then if we can remember back to Public Finance 101, the incidence should be the same. It doesn't matter if you subsidize up or down. The incentive should be the same. But this matters when you have trade and different jurisdictions, which way the global technology prices are going. Because really, when we think about the goal, ultimately, it's not just driving down the cost of renewable energy in the Netherlands. We want these costs to come down globally. And this is important. We see a lot of developing countries are really pushing to try to use 100% renewable energy by 2050. You'll notice that a lot of these are sort of small, are highly threatened by sea level rise and developing. But we see this really when we look at where energy demand is going. So this was from the International Energy Outlook, sort of looking at where energy demand is by 2020. And so we see here, so you know, the EU and the US were big economies, but really the energy demand in the rest of the world is going to be several times larger, and you know, and at least 50 times larger in China. So so it's really important that we bring the cost down for those guys on the right. So I've been working for a while on trying to sort of make the market case. Well, so how do we value the benefits from, you know, extra support to renewable energy on top of what we might get from carbon pricing or emissions trading systems? And so I have some earlier work with Richard Newell and Louis Prionas. So we're trying to think about, well, what's the value of learning by doing, as you know, the spillovers from learning by doing as a market failure. And so we get sort of plausible values of, you know, so the efficient subsidy would be maybe 1 cent per kilowatt hour levelized for wind. Solar is a little bit further up the learning curve, so about 5 cents. And now with this new work that I've been doing, it's called Strategic Subsidies for Green Goods, thinking about, well, what's the value from global deployment? What's the value from scale economies? And there we actually get some quite, some larger values on the same order as learning for solar. So let's just think a little bit of what this model looks like. So let's just take this is a partial equilibrium model of the electricity sectors, and I've got 4 different regions. So I've got the sort of the jurisdictions that are also manufacturing the technologies, so that would be the US, the EU, and China, and then everyone is consuming the technologies in order to generate electricity. So these are the big guys in terms of you know, renewable energy manufacturing. And just to cut, since I don't have a whole lot of time, to cut to the chase. So now I've got so multiple market failures in my model. So I've got a sort of a concentrated upstream market. It's not perfectly competitive. It's Cornell competition, and then I also have this carbon leakage effect. As we care about we care about emissions in all of these countries. Maybe I should go back here. So the exporting countries, they're also going to care about the you know, the welfare of their industry and the terms of trade. But we also care about where global emissions are going. And part of the issue is that you have these exporting jurisdictions. If you drive down the price of the technology, that hurts their terms of trade. So it's better for global emissions because people adopt the technology, but it's worse in terms of the value of their exports. Whereas if they instead choose to subsidize deployment, that helps, you know, deal with emissions in their jurisdiction. And it also props up the prices. So they make more on their technology exports, but to the detriment of the rest of the world, and then to the detriment of emissions in the rest of the world, which is relatively dirty. So let's just suppose now, so we've got multiple market failures. The optimal policy now would be Ian's global carbon price. So let's say the social cost of carbon is $30 in this case. We've got imperfect competition and also some scale economies. So those are upstream market failures. So then we'd want some subsidy upstream. And so this is, if the first red bar is the welfare gains that you get from this optimal combination of policy. So now let's start looking at what happens when we arbitrarily sort of restrict the policy levers that we have. Suppose now that we can only have a global carbon tax at the social cost of carbon. So we can't subsidize upstream, perhaps because of WTO rules, which don't have any green exceptions, any environmental rationale exceptions for subsidizing industry. Okay, so we've lost a fair amount, almost a quarter of the potential welfare gains from optimal policy by not being able to internalize these upstream market failures. Now suppose that we don't have a global carbon tax, but we only price carbon in these major emitters, the EU, US, and China. So now we've lost 2/3, at least, of the potential gains we could get. And so here's the point of this study. Now suppose we have optimal subsidies, so no carbon pricing at all, and we just subsidize these technologies. This is going to be a mix of upstream technologies to get at the upstream market failures, and then a little bit of downstream to make sure that that we have an efficient deployment around the world. Because remember, this is a rough policy. Without the carbon price, you don't have the right signal between coal and gas and all the and conservation, all the means that we have to reduce emissions. We're just subsidizing renewable energy, and in different countries, we'll be displacing different amounts of emissions with that. But what's really telling here is that even despite how rough a policy this is, it's actually, we get more of the welfare benefits than this just sub-global carbon pricing. So this is why I'm calling for a little more sort of nuanced view of, in this world of, the Paris Agreement, where everyone's kind of agreeing to a hodgepodge, we don't have global carbon pricing, this opens up actually more room for technology policies. This is not to say that that's the ideal, because obviously you're not getting as much as if you could have the right amount in combination with global carbon pricing. But in the world with carbon leakage, you may actually do better with optimal subsidies. And so I think, so this is from some older research with Richard Newell. So it is kind of a different story. So here, this not taking into account the emissions leakage, we found that optimal policies do address some of these upstream failures, but if you can only have one policy, the least costly policy would be emissions price. In a world with leakage, that can actually change. I think that's already had this. So then just the last point, though, is part of this was inspired by sort of the controversies now in terms of trade policy in the WTO. So if you think that the WTO restricts our ability to engage in just flat out subsidizing our green industries, and all we're left is with downstream deployment policies. So this is even with scale effects. So even despite the fact that that pull policies now actually are effective at bringing down costs, they're still a lot less efficient than than going directly at the upstream market failures. So I think I will conclude there that it's important to remember that we are in a second best, nth best world, and so it requires a lot of more nuance in terms of our policy recommendations, both on the economic side and I think the technology side. I'm not going to turn in my economist card and say that carbon pricing isn't important. It's still very important, but it isn't enough. And so just for the same reasons that we have to address competitiveness effects in carbon pricing to avoid carbon leakage, we also need to think about that on the technology side. We should address the global effects of technology policies to maximize negative leakage. We want to bring down the costs for everyone. So thank you very much.
So, as economists, we are learning today that we have at least two market failures. First, we started with the global carbon problem, and we addressed it with the carbon tax. Then we learned that, okay, there's a second problem in our complex world. That is, we also have some kind of problems in relation to competitiveness internationally, and which is directly related to technology spillovers. And I think this was a very challenging introduction as well. But the third introduction makes life even more complex. So I'm very interested to hear more about that from our third speaker. So may I ask you to come to the floor, and Michael Greb will tell us more about the complications. And I think the EU may be not so bad after all with its policy. We'll see. Okay, let's try. To get this on there.
Just while Herman's pulling that up. Ah, okay.
Sorry.
No, it's
yeah, you can use it.
fine.
You want to walk around? That's also possible.
No, I'll speak there. That's fine.
Okay.
That's fine.
Yep.
So, thank you. Okay. So I'm conscious this is the last talk of the conference. Thanks for sticking around. I will try and make it a little different, even perhaps a little entertaining, if my voice lasts. And I apologize, you can probably hear I've been nursing a chest and throat problem this week, so I haven't actually seen as many of you as I would have liked. But the brief for this talk that Herman and Bert gave included discussion of policy instruments, carbon pricing as a prime thing, but complementary instruments as well. So I thought I would go the whole hog, if you know the expression, and offer a title called Different Therefore Equal, reveal myself as an aging hippie with some lines from a song by Peggy Seeger of that title, which asked a series of rhetorical questions about, is A better than B when A and B are fundamentally different? And I hope that you'll see what I mean a little bit by the end of the talk. So I will cover a bit about carbon pricing, basic points on theory progress, link it a bit to the high-level European framework, argue that we need to broaden things even beyond the way that Caroline has just done excellently. I will argue we need to go even further and hone that on to what I call 3 pillars of policy. Now, Herman did also say that he knew a little of my work and it tended to be a bit sort of broad and conceptual. So I'll try and give it a little bit of meat in terms of some national experiences and technology experiences. So I chose a business person because I think many economists here would automatically agree with that statement. The carbon price is the most efficient and cost-effective tool. I just want to illustrate an aspect of it in the following way. You'll see in a moment why, which is to start with a very simple, very fundamental thing. Call this technology frontier or whatever you want to call it. I call it the best practice frontier, which basically says the more inputs, which is the vertical, the more outputs we can get, and that rational people will operate at that frontier and tend to increase their use of a resource up to the point where it maximizes their welfare, which is the horizontal. Great. There are millions of such frontiers in our economy, which is why markets tend to be very good at resource allocation. The interesting thing, though, is when we think about climate change or environmental damages generally and consider the vertical here is now to say is actually energy and carbon emissions, then there's an externality which means actually we're not, after all, better off by consuming more because there are hidden costs and they will pull that curve back. The more we emit, actually at some point we start to decrease our welfare. Fine. From that flows the theory of externalities, which is we recognize that climate cost, we internalize it with the carbon price,